Okay, so I'm gonna go. So it says important. The older logs agent is deprecated. CloudWatch includes a unified agent that can collect both logs and metrics from EC2 instances and on-premise servers, right? So we have seen multiple times here that this is our system, right? This is our application, Amazon.com, or any application that we choose. We have a web layer, we have an application layer, we have a database layer. So we want to monitor these things. These are the design principles that we use to design our application, right? So we want to monitor security, account security, user security, data security, network security. We want to monitor the private and public load balancers, private and public subnets and load balancers. We want to monitor the database for performance, right? Database stores information. So when data comes and is stored here, applications need to read the data, right? So when monitor high throughput, low latency, fault tolerance, all those things. So for us to be able to monitor these EC2 instances and these databases, we must collect something called logs from them. Logs, right? A log is simply uh, a timely activity that occurs on that server. So the log is a log, L-O-G, a log, right? So everything that occurs in that server is logged. So let's go to EC2 and let's go to AWS and create an EC2 instance. And then we're going to go ahead and install the CloudWatch log agent, because for us to be able to collect logs from that EC2 instance that runs our application right here, this EC2 instance run our application, run our website, right? Amazon.com/help. We need to be able to install the CloudWatch logs agent on that EC2 instance. Even with Datadog, you need to install an agent for all these monitoring tools. When we start doing monitoring, which is the main cloud SRE, right? This is the main cloud SRE notes. You guys have these notes. I've given you guys these notes before. These are the things that we're going to be doing, right? Understanding the application, the users connected to the application, the load balancer, the web servers, the application servers, right? What are you going to be monitoring all the servers, right? The monitoring piece, the types of users. So we need to go into all this stuff and then we're going to start monitoring them, right? So you see how DevOps is huge, but we're only going to focus on the upside of it. So we need to monitor, we need to operate, we need to deploy, we need to release. This is our side of things, right? So we're going to learn about SRS abilities, how to detect issues. Like I said, security, the application health, the database, the system health, application functionality. These are things that we're going to be focusing on, right? So we need to know what we're monitoring, right? And this is how we're going to monitor it. Security, we're monitoring phishing attacks, unauthorized deployment, we'll monitor all these things. And these are the tools we're going to use. SolarWinds, Intruder, AWS Guard Duty, right? Splunk, Nagios, all these tools, we're going to see them. So it's better we'll start now, and understanding and focus on monitoring. We'll start now. You can look for a job online that you can go look for a job called Cloud Monitoring Engineer. Everything is about monitoring. You know, that job, this is the job. Boom. You go look for all of this particular job. Right? CrowdStrike is hiring for these jobs. Right? Indeed.com, cloud monitoring jobs. That's it. 197 days. All these jobs is just cloud monitoring jobs. Cloud efficiency optimization by Geico. That's what they're asking for. They're asking for, what is that? What are they asking for? All right, reliability engineer. Or is it just it's not? The Hartford, Connecticut. Right. So we're gonna focus on these things, right? Test automation, all these things like observability monitoring. Dynatrace, Splunk is a plus. We just saw here Splunk and Dynatrace. You see that? So we're gonna learn. We need to start learning these tools now. CloudWatch, right? Dynatrace, OpenShift, AWS, experience in the cloud, Let's just go directly and start learning the main thing. We focus on learning only these tools, Kibana, Splunk, App Dynamics, and boom, we'll get the job immediately. Okay? Let's not waste any more time with this fundamental. Let's just focus on learning monitoring. And by December, we're applying for jobs. Sound like a plan? However, though, if you have difficulty understanding what we're monitoring or why we're monitoring it, please ask me. Please ask me. We've done a lot of networking fundamentals already. Client-server relationship. Everything we do from now on will revolve around that client-server relationship. The 7 layers of connection. Because when you start troubleshooting issues, Tolu,
Hi.
when you start troubleshooting issues, you need to know what? The 7 layers, right? Which layers are on the client side?
1 through 3.
Which layers on the server side?
5 through 7.
Which layers in the internet?
4.
But Chris, that's not how you're gonna answer in an interview, though. You got to make a full sentence, though. Right? You're
Fair enough.
professional. They're gonna ask you which layers of the OSI model is on the client side. How would you answer?
On the OSI model, the side that's on, or the layers that's on the client side are layers 1 through 3.
Then they'll ask you what is layer 1, 2, 3. You see what I'm saying? If you just
Yep.
said the client side is the physical layer, the data link layer, and the network layer, then they're not gonna ask you a follow-up question.
Got it.
So guys, try to answer the question. There's something called completeness, conciseness, concise, and concrete. This is what you should use when answering your questions. Be complete, be concise, and be concrete. I'm going to be adding you guys to this interview questions here. So you can start studying for it. Right. There's a lot of stuff in here. You need to know this SLO stuff, which you're gonna get to it, right? It's a lot of stuff you can access. I'm gonna give you guys access. Let me put this in the chat, see if you guys can access it. Copy link to notebook, view only link. See if you guys can copy this link and put it in the chat. Let's see if you guys can access that notebook. Okay, now I'm gonna open it up. You can only view it, or you cannot change it. Okay, don't try to change it. Okay, so we are monitoring databases, applications, web servers. Our focus is, right, all these things. So I want to learn about step 1, step 2 tickets. We're going to go into these things later, but for right now, let's even learn how to, these are the tools about monitoring, right? You want to monitor logs, you want to collect the logs. The first thing you monitor is install the logs agents. So you can collect logs from the server. Okay, that's the very first thing, logs. They will learn all these other things, okay? They will learn emails, alerting, then you learn on call and how to debug issues and stuff like that. Okay, for right now, our focus is to do this assignment, which is to install and configure CloudWatch logs agent on a running EC2 instance. What's the meaning of configure? What's the meaning of configure?
Install.
No, you have install here. What's configure?
Configure means install and customize it to your needs.
Yep, that's the meaning of configure. You customize it because when you just install something, it's very basic, right? It's the default. So you need to configure it. You need to customize it. So Isabel's current when you buy a new phone or you buy a new laptop or something, you have to customize it to your taste. So configuration is customizing it to your needs of the company. So look at what they said. The older logs is deprecated. Deprecated means it's no longer supported. It's done. It's not discontinued. CloudWatch includes a unified agent that can collect both logs and metrics from EC2 instances and on-premise servers. For more information, see Getting Started with CloudWatch Logs. If I were you, I'll right-click and open this in a new page and just leave it there. For more information about migrating from older CloudWatch log agent to the unified agent, see this. I'll open it and keep it to the side. The older logs agent supports only versions 2.6 to 3.5 of Python. Additionally, the older CloudWatch log agent doesn't support Instance Metadata Service version 2. Instance Metadata Service version 2. Instance Metadata Service version 2. That's what this means. IMSV 2. If your server uses this, you must use the newer unified agents instead of the older CloudWatch log agent. The rest of this section explains the use of the older CloudWatch log agent for customers who are still using it. Tip: CloudWatch includes a new unified agent that can collect both logs. They repeat it again. They repeat again. They repeat what they said up here. They repeat it down here. Additionally, they repeat it again. So that's why I was asking you guys that reached out to me. Make sure you read this very well. What did they say here? If your server uses this, you must use the newer unified agent, which is where using the unified agent here. That's what I'm saying. You have to read in between the lines. You have to read in between the lines. Okay. Configure the older CloudWatch agent on a running EC2 instance. Let's create an EC2 instance. Let's go create an EC2 instance. I'm gonna go here, log into my accounts. If I'm too fast, please let me know. Some people told me I was too fast last time. I mean, we're already in November. We already have 2 months left, so we have to push, guys. We have to push. That's why we have to start having class on Saturday, if possible, or the project on Saturday. So this is my monitoring _ server. So it's EC2, the Linux instance, leave it at default. Everything is default. I'm going to create a new key pair. It's called a monitoring key. Create key pair. And then creating your security group as well. Everything default on launch instance. Okay. And while it's creating, let's go back here. It says the CloudWatch log agent supports IAM roles and users. This is the permission security. If your instance already has an IAM role associated with it, make sure that you include the IAM policy below. If you don't already have an IAM role assigned to your instance, you can use an IAM credential for the next steps, or you can assign an IAM role to the instance. For more information, see attaching IAM roles to the instance. So you're going to open up the IAM console. Right click, open up. Choose roles. Choose the role by selecting role name. Do not select the checkbox next to the name. Attach policies, create policy. So go here, choose roles right here. You can watch me do it, guys. I recommend that you watch me do it first and then you do it later on. I don't think you should do what I'm doing it. Because some people are trying to do what I'm doing it. That's not how you're going to learn, guys. Trust me. You need to watch what I'm doing, learn, ask questions, and then you do it after. Or the first time I can do it on my own, you watch, and then second time, I watch you guys do it. If you have 2 screens and you're trying to follow what I'm doing, and you don't understand I'm doing it, then it's an issue. Understand what we're doing here, guys. Don't just do it because you want to do it. Because when you go to the interview, they ask you questions, you don't understand what you're doing. We're trying to install CloudWatch Logs. CloudWatch Logs is an agent. It's a software that when installed in an EC2 instance, it will capture all the activity on that server and push it into a log file. And we can go look at the log file and see how much memory or CPU you have consumed. That's what CloudWatch is. Okay? So we're trying to configure this server to have permissions. We're going to attach a role. A role is simply a set of permissions. We're going to attach permissions so that this server can create a log group. It can create a log stream. It can put log events into the log group that I created, and it can also describe the log stream. This is what the permissions are. We're giving our EC2 instance, this EC2 instance here, we're going to give it permissions to perform those things. This monitoring server right now, if you go to security, it has no IAM role. See, IAM role is empty here. So it doesn't have any permission to do anything. So this step that we're doing here is to grant this EC2 instance permission to perform these actions. Look at the action here, create log group. So when we install the log agents on this EC2 instance, this EC2 instance will be able to create a log group, create a log stream, put log events in the log stream and the log group, and then describe the log stream. So that when we go use CloudWatch to query the logs, we can see, oh, we have used so much memory and CPU. That's what this is about. Is that clear? Any questions on that? Everybody put your camera on, guys. Come on, man. I'm not going to do this. Everybody put your camera on. Every time you need to give permissions to a server to perform some actions, this is how you do it. You attach a role to that server. Now, this is the hierarchy of it. A policy is a set of permissions. For example, create EC2. That is one permission. Delete EC2. That is one permission. Describe EC2. That is another permission. So when you take all three and put them together, this becomes what? An EC2 policy. That's it. That's it. A policy is simply a set of permissions. Now, what is a role? A role is a set of policies. How do you spell today? Policies or permissions. So here you have create EC2. And then you can also attach the EC2 policy here, because this is a permission and this is a policy. So we don't attach policies directly to servers. We attach a role. So this role here we can have another permission that says, which other one can we say? Delete. We can have something like that says monitor EC2. This is another permission. So you bunch all of these up, all these three up, right? And you call it what? Monitoring role. And then you take this role and you attach it to your monitoring server. That's it. It's very simple. So now this monitoring server can create EC2. It can create, delete, and describe EC2 because it has an EC2 policy. And then it can also monitor EC2. This is the right way of providing permissions to a server. You attach the role, monitoring role to this server. You can also attach individual policies like this, to a server, but it's not best practice. It's not the right way to do it. Because when you do it one by one like this, it's difficult to manage it. There are over 1,000 permissions in AWS. If you keep adding them one by one, it becomes difficult to manage. If you put them all in one row, like a monitoring row, and you put 100 pods in this row, you can go, if you want to control, if you want to remove something, all you go do is edit this row, remove one from the row, remove this from the row, and this row is updated. The row remains attached to the server. The row remains attached to the server. So now this row has create EC2, delete EC2, and describe EC2, and it has monitor EC2, but you remove create EC2, but it's still there. If you go now and edit this policy and remove delete EC2 from here, guess what happens? This EC2 policy only has create and describe, because this policy was used to create this row, and this row was attached to the monitoring server. So now when you come in the morning and log in to this server, you can't create EC2 because they've updated the policy that was used to create this row. Is that clear? Or do I need to explain again?
Can you say that one more time? It froze up from.
Okay, let's go do security. Let's just go to the notes. Let's go to IAM. That's IAM. Let's just go to that. That's IAM. IAM. Let's just do IAM. There you go. Let's do IAM. Okay, let's begin from the start. IAM stands for Identity Access Management. In IAM, we're going to learn the features of IAM. We're going to learn AWS policies. We're going to learn what AWS users are. We're going to learn what IAM groups are and what IAM roles are, and then IAM best practices. IAM is the most basic service and the most used service in AWS. The most basic and the most used service at AWS. IAM is made up of users, policies, groups, roles, and that's it. That's it. That's all IAM is made up. That's all you see. That's it. That's it. It's very, very short, very, very easy, right? You can become an IAM engineer, and that's all you do, and make like $90,000 or $80,000. That's all you do. It's IAM security. That's all. It's very basic. It's very rudimentary. Once you understand it one time, that's it. It doesn't change. It's the same thing every day, every day, every day, every day. Done. All your work is doing is adding permissions to a server, removing permissions, add permissions, remove permissions, modify, delete, recreate. That's it. It's very, very easy. Very, very easy. Okay. Most people are doing it. Most people do IAM. Most people do Azure IAM, and that's all they do is Azure IAM. They don't do nothing else. That's all they do. So IAM is a web service that helps you securely control access to AWS resources for your users. What are AWS resources? AWS resources are the things like, go ahead, someone want to answer.
I was saying IR resources are the services that AWS provides to its users.
AWS resources are the services that AWS provides, correct. These services, VPC is a AWS resource. IAM is an managed access resource. S3 is a resource. CloudWatch is a resource. All these are all AWS resources, right? You have databases. You have managed SQL DB, that's a resource. These are all resources. These are all AWS resources. Machine learning, these are all resources that AWS offers. So when they say that IAM it's a service that helps you securely control access to AWS resources for your users, it means that you need IAM access identity management to control who has access and who doesn't have access. What is access? What is access?
It's like permission.
Try to answer questions in a full sentence.
I would say access are rights or permission to, maybe get logging into a system or, having certain privileges to, certain.
Let me ask a better question. What is access to Instagram? Anybody can answer, guys. What's access to Instagram?
Access to
I
Instagram is okay. Go ahead.
okay, I wanted to say access is like like a permission to enter into a system. Like you can get into you can get into a system and just watch, and now it now depends if they give you other permission to do some other modification and all, they can add other permission to it, but access is just to go
That's
into
it. That's it. That's what it is. That's how you answer questions in an interview. Even though you're making it's okay. Trust me. I make a lot when I because I make access is it's a right, to access. I even use access again. Guys, it's natural. It's okay. If you give the perfect answer in an interview, they will think you're reading from somewhere. You need to make that I'm trying to give you the right answer. Just give me a second. I'm thinking about it. Yeah, permissions is the right to use resources and authentic, like it's genuine, it's natural. It means you know what you're talking about. Even though you're reading, from here. Oh, let me tell you guys, if you know you're reading from here, what's SRE? SRE is SRE is people that do crisis managers or problem solvers, proactive maintenance, or it's coming out like it's natural, but you're reading it from somewhere. That's when they will hire you. That's when they'll hire you guys. You need to be able to speak freely and not panic. Even though you make the doesn't mean you don't know. It means you're thinking. That means you're thinking. They want to hire people who are thinking. We want to have thinkers, critical thinkers. Because when you have critical thinking, it means that when you experience a situation that you don't know the answers, you know how to resolve things. You can Google it. You can ask a coworker. You can call a friend. Those are the kind of people that I want to hire, right? So IAM is pretty much the service that helps you control that access, right? So you use IAM to control who can use your AWS resources. So there's two things in IAM: authentication and authorization. The people who can use your AWS services, you have to do authentication for them. And what resources they can use and in what ways is authorization. So you can have access to my AWS accounts. That's authentication. You can log into my account. That's authentication. Authentication is when you log in, you put your password in and you log in. You have been authenticated, you're logged in. But now, what can you do when you log in? Remember when we talked about this thing? Clients, server, right? And this guy senses what? His credentials, username and password. And equals to what? Authentication. And he logs in. And the server sends a request. And the server sends what? What does the server send back? Everything revolves around this thing, guys.
Feedback.
What does the server send back?
The server sends back feedback
Response.
to the client.
You send it.
Kwasi, just help us. Kwasi, help us. What does the server send back?
You send a response.
Response. Guys, you need to study. I need to study. You need to study.
But I said feedback now. It's not.
Response is not feedback. No, it's not funny. I'm sorry, man. You're laughing. It's not funny. You need to follow instructions in succeed in IT. Response is not the same as feedback. This is a technical term. This is an IT term. In the logs, you're going to see the word requests. You're going to see the word response in the logs. A response has a code. A response code in the logs equal to 200. 200 means it's okay. Everything is good. That's the response code. And a request code is going to be a custom code based on the request that comes in. And then you're going to see an error code. Error 404 or anything 400 and above is some client-side error. Client-side error. And anything error 5, 504, 503, 505, 506, 508, 515 is what? Server-side error. You need to know this thing. This is monitoring. This is your job. So when we start doing logs, you go into a log and you see the error 4, 404, 41, 403. You know to look on the client side. If you see error 501, 504, 506, it's server side. If you see response 200, okay, that means that the server responded, everything is fine. When a client sends a request to a server, and the server doesn't respond, or it responds to the 504, it means the error is issue is on this side. If the client sends a request and the server doesn't receive the request or rejects the request, and you see a 404 error, the error on this side. Everything revolves around this client-server architecture. If I were you, I would study it every day, until I understand everything about it. You can even go Google it. Client-server relationship. It's on Wikipedia. And read everything about it. It's on Wikipedia. Read everything about it. Client-server model is the oldest thing in IT. There's many much information about it. Read about the history about it. Look at that. There's so much about it. It's the oldest thing. It's the fundamental of IT. Client server. Client server. Everything we do in our lives is client server. You do it every day. You send messages every day. You answer phone calls every day. You watch TV every day. Everything is client server. If you master it, it will really help you easy. But again, it's requests and response. Request and response. In the logs, you will see the word requests. You will see the word response. Please don't forget. Okay. So you can log into my account. You have been authenticated. This is authentication here, right? Authenticated. And now when this client server, he cannot do anything because he doesn't have the authorization. So authorization refers to what resources you can use and in what ways you can use those resources. You can log into my account, that's fine, but you cannot create EC2. You cannot monitor EC2. So creating a policy or giving you permissions, that's their authorization to do things. So this role, everything that we just did here is authorization. Authentication is just giving you a username and password, creating a basic user for you, right? We talked about users here. Authentication is just users. While authorization is what? The policies and the roles. Okay? So accessing IAM, you can work with AWS identity management in the following ways. You can do it using the console, using the AWS command line interface or SDKs. We're going to focus on these two, not the SDKs. SDKs is a software development kit, which is the one that developers use. So what are IAM features? Centralized access control for AWS in which you can administer users, groups, roles, and permissions. So the IAM service, which is this service right here, you can create users here, you can create roles, you can create policies, everything here. You see, I have 6 users, 46 roles, 13 policies, 1 person. If you look at my users, I have this Dorma user, I have Father Joe, I have 5 friend admin, lines admin, I have Sedona, I have Terraform, I have all these users here. You can see how old I've been in there, right? So look at roles, I have all these roles. In these roles, you have policies attached to them. You see, This role has one policy attached to it. If you go back here and look at this other role, it has two policies attached to it. This policy has many sets of permissions. The permission is here, easy to describe availability zones. That's one permission. So that policy has many permissions. Create stack, create these, all these things. So these two policies make up this role. You take two policies, 1, 2, and you create and attach it to a role, and the role is called AWS Control Tower admin. Now, in these roles, we have custom roles that we created, and we have the ones that comes with our account by default, right? So we can come here and filter. Where is it? Right here. You can look at the role. I haven't created roles in a while. So that's pretty much what roles are, just a set of them policies, right? AWS managed roles or policies, and then you have customer managed policies. These are the ones that I created manually. So Devo custom policy. And in this policy, it has S3 and EC2 attached to it. You see that? So authorization is just pretty much giving you the right to do some stuff. You can have access. Okay, let's say we live together in the same house, Ayamba. You have access to the refrigerator that we live in the same houses, right? But do you have the right to eat my jollof rice or my pepper soup?
No.
Exactly. You have been authenticated into the refrigerator, but you don't have the right to eat my food. So that's why authentication is different from authorization. Unless I say, yes, okay for you to eat my jollof rice, before I can go eat my jollof rice. Okay? So IAM features has integrated with AWS to provide granular level access control. It's a free service that you don't pay for it, right? And it's available in all regions. IAM uses identity federation between your corporate directory and AWS. So on the job, most companies have something called identity federation, which is their corporate directory. When they hire you, they collect your name, email address, all that stuff, and they put in their directory, right? So they use that to grant you access, right? You don't have to create a new user in AWS. They'll grant you access to the roles and everything already created in AWS. So they use existing corporate identities to grant secure access to AWS resources. So these are the key features of IAM. You have multi-factor authentication, which we're going to enable. They have a password policy. That's why they tell you to create a password that is at least 6 or 8 characters, 1 capital letter, 1 small letter, 1 special character, and after 90 days, it will expire. That's a password that the company creates. And then it also has a payment card industry data security standard. This is what allows websites to process credit card information. Then you have identity information as well for insurance, identity federation. You have secure access to AWS resources. You have granular permissions. You have shared access AWS accounts. So this is a shared access. You can grant permissions to users to access and use resources in your AWS account without sharing your password. So this is the admin user. I'm going to go create users group A, group B, group C, or individual users. I'm going to create Chris. I'm going to create Cam. I'm going to create Kobe. So for Chris, I'm going to give Chris permission to access EC2 and to access S3. But I'm giving him based on his job role. On the job, they only give you access based on your job role. Based on your job role. Here, this is Cam. I'm giving him access only to storage because I want him to monitor only storage. So it's a storage monitoring engineer. He's going to monitor the storage. And then here, I'm giving access to Kobe. Kobe's on monitoring databases and storage. These two. But he cannot monitor this because in this EC2, Chris is monitoring that. And Chris is also monitoring storage. So he's monitoring storage and databases. Chris is monitoring EC2 and storage. And then Cam is monitoring storage. So in this scenario, who has the highest power to monitor storage? In this scenario, Chris, Cam, and Kobe, who has the highest roles or permissions to monitor storage?
They all monitor storage.
If you're going to answer, please make it answer.
The three users, they all have access to monitor storage.
Yes, but who has the most powerful permissions to monitor storage?
I will say the second one. The
The
one
one in
in
the middle, right?
yeah.
Yes, Cam. These guys are monitoring this storage because EC2 uses storage to store files. Database right here uses S3 to store some backup files. S3 says you store backups here. In every service or resource AWS, there's always a higher user that has more permissions than you. So let's take this. Let's dive into this a little bit. Sorry. I'm going to dive into this. Once you understand this stuff, man, you might just go be an IAM engineer next week. It's very, very easy. Let's go here. Let's go here. Let's put it here. Boom. So that's Cam. That's Cam. No, that's not Cam. That's Cam. That's Chris. And that's Kobe. Okay. So Kobe monitors databases, Amazon Relational Data Service, database service. This is what it is. So what does he need to monitor databases? What permission does he need? He needs describe RDS, which is RDS stands for Relational Database Service. Okay. So that's what RDS means. So he needs describe database. He needs list database because there might be more than one databases, right? So you need list database, describe database, list RDS, describe database, list RDS, and then monitor RDS. That's what he has. For S3, he has list S3. He has describe S3. That's what he has for this, for S3. Okay. For this guy, Chris, what does Chris has? Describe EC2, list EC2, monitor EC2, and since it's powerful, probably create EC2 as well. So he has create. Then here, Kobe is powerful as well to create RDS. Okay, but they both, Chris and Kobe both have the same lists. They can only list and describe S3. So guess what, Kobe, what will Cam have? After you've seen that, what will Cam have? Come on, guys, tell me what Cam will have. After seeing this permission that you see these guys, like, what will Cam have for S3?
Describe S3.
Mm. Monitor.
So when it comes to S3, who has the most power?
Come.
Thank you. And that's how it'll be on the job. That's how it'll be on the job, guys. If you are monitoring RDS, and your job is to monitor RDS, and RDS stores backup files in S3, don't wake up and say, hey, Cam, why can I not create S3? No, that's not your job. If you want to create an S3 bucket, you open up a ServiceNow ticket and say, hey, Cam, I have a ticket to create an S3 bucket, and Cam will create a bucket for you and give you permission to list it and describe it. That's it. The more permissions you get in a job, the more work you want. You're only going to be giving access and permissions to the things that is concerning your job function and your job role. If you don't have access to some things, please avoid clicking around. Clicking around. Because we are capturing, every time you click, we are capturing it. If you click and go here and go click here, we are capturing it in a log file. It will show up in the logs and they say, oh, he was snooping around. He went and looked at cloud management. He went and looked at the bill. They'll see it. Please avoid clicking around. If your job is an EC2 guy, when you come to work, just go to EC2 and just stay you there and do your job and go home. Avoid clicking around. You go and try to click on the bill of the company to see the bill, it's none of your business. It's none of your business. They will see what you're clicking around. Avoid that, please. Avoid it. I'm begging you. Okay? So that's how I do the job. Cam is an S3 monitoring engineer. He can create S3, he can list it, he can describe it, he can monitor it. Kobe cannot create S3. Chris cannot create S3. They can all log into AWS account. They can all log in. Yeah, they can log into AWS. Yes. Chris can go to S3 and list and see S3 bucket, but he cannot delete it. He cannot create a new one. Kobe can go look at it and see the bucket, see the data, yeah, but he cannot delete it, create a new one. Can create a new one. Can list a new one, can describe a new, can monitor it, but you cannot delete it. You can create a database, but you cannot delete it.
So putting into perspective, right?
Yes.
It's just like, let's assume that we are in a Scrum team, and then let's say the Scrum Master gives like the developers permission, Jira permission to create stories. But let's say the business analyst can only view the story, he cannot create it. Is it the same perspective?
Yes. Yes. Sometimes you can only view the story, you cannot create a story, but you can add comments to the story.
Yep.
Right? Roslyn, you want to
Yeah.
add to that? We don't create stories. I don't create stories, but the stories already available there.
Yeah, basically the product owner creates the stories than the developers.
Yeah, I can go pick a story, but I work on it and add comments to it, but I cannot create stories. I don't have permission to create stories or epics or
Yeah, I'm just giving that as like just to see the perspective of how the roles and
yeah,
stuff.
everyone has their job function. Yeah. Because if I'm an architect and I have to create stories and then I'm doing everybody's job. Then if I'm Kobe and I have permission, I have all permissions, then Cam and Chris should go home. They should be fired and go home. Why are they here? If I can do everything, right? So that's why if you get permission to do everything on the job, you're in for a lot of work, man. And they should be paying you more money. The more access you get, the more permissions and access you get on the job, the more money you should be making. That's a hint. So don't compare yourself with another person. That person has more access than you, the chances that I'm making more money than you. I'll just give you guys an insider. That's a trick that you should know. If someone has more access than you on the job, they're making more money than you. But hey, that's not your business, right? Just get your own and go home. Don't stick your own share and go home. Don't be comparing yourself. So we share access, we grant permission to users to access and use resources in an account without sharing password. So how we do that? We're using roles, right? We use roles to do that, right? Those roles, we assign roles. This guy has this particular. So all these permissions You combine all of them. You combine all the permissions in here like this, and you create something called a database monitoring role. And then, so whenever Kobe logs in, he will just assume that role. So the next time we want to add Kobe's permissions, what do? We just go to this role and modify the role, and we can add another thing. Let's say create logs. And when Kobe comes in and just logs in again, he can create logs. That's it. And you'll just update here automatically. So it's easier to manage permissions like that. But if we're giving it manually one by one, we'll have to come and edit this user, add logs, and then it might affect Kobe's connection. If Kobe is already connected and working at 1 p.m., we have to come and modify his role. It might affect his work. But when we modify the role, it doesn't affect his work. That's how we don't do individual permissions to create a role, and then we'll just manage a role. We know what's database role. We know what's in, EC2 monitoring role, like that. We'll create an EC2 monitoring role. That's it. So Chris just assume this role when it comes to work in the morning, and that's the role. When we hire a new employee, let's say we hire a new employee. Let's say we hire Isabel. Because Chris' work has increased. There's many more EC2 instances. He's heavy. You're gonna do it alone. We'll hire Isabel as a S3, and we'll add her to this particular thing. And guess what? Now we just give EC2 monitoring role to Isabel. That's it, done. Easy. So Chris has EC2 monitoring role, and Isabel has the same role as well. We don't have to go to Isabel and give her permissions manually. No. We'll just attach that role to her. Done. It makes it easier. We'll hire another new person, Joe. We'll hire another new database monitoring guy. We'll hire Joe. Joe just comes to work, boom, and assumes database monitoring role. That's it. You see that? You see how easy it is when you use roles? That's it. We'll hire Joe, and boom, Joe just joins the company and joins that role. Done. And then that's how the companies keep growing. If Cam quits, when Cam quits his job, if he quits, we'll just come and take the S3 monitoring role that was already there and just give it to Rosalind. Done. We don't have to create new things again, one by one. No. I had there. That's it. I'll just delete Cam. That's it. So that's the management of IAM. Very, very easy. Any questions? So granular permissions allow different permissions to various users to manage their access to the These are user access to specific services, like we just saw. Specific services, you can only have access to EC2 or databases. You cannot get everything. Your specific services, specific permissions for specific actions, specific access to resources. For example, development team has access to instances and EBS volumes. This same development team doesn't have access to other instances. This same development team have read-write access to volumes, but they don't have admin access to everything else. Secure access is securely allocating credentials that applications on EC2 instances require access to other hardware resources. So in this case, an EC2 instance is your application. This EC2 instance needs to connect to a database. So what would you use to connect to the database? You use a database role. A database role, which gives you EC2 instance permission to list database, describe database, monitor database, query database, read from database, write to the database, so the application can connect through IAM roles and permissions to do actions on the database. Same thing with the S3 bucket here. This application can list bucket, describe bucket, create bucket, read bucket, write to bucket, all these things. This instance acts as a user. So we can give him permissions to do those things. That's secure access. And then identity federation is simply when we don't want to create users from scratch. We want to allow users to use external accounts to get temporary access to AWS resources. You have a Gmail account. So instead of you creating a new username and password, you just use your Gmail account to log in, or your Facebook account to log in. Has anyone ever experienced that? Let's say you want to create an Uber account. Uber uses Gmail. Don't create a new username, just use the Gmail account to log into Uber. Have you guys experienced that? Yes? No? Maybe?
Yes. Yes.
Okay. That's what identity federation is, when you use your third-party account to log into an application. Okay, so Amazon offers that as well. They offer Facebook, they offer Microsoft Active Directory, also Google as well. So you can use the Google account to log into AWS. You don't have to put the username and password all the time. So this is identity information. So you say you can log, monitor, and track what users are doing with AWS resources. This is what I was talking about. They're called CloudTrail logs. Every time you click on AWS, everything you click is one log. It's capturing everything that you're doing. It's capturing everything that you're doing. So what happens is we log, we monitor, and we track what users are doing with AWS resources. So this account A, account B, account C. Account A is the IAM admin with full control. So account A can connect to account B using CloudTrail logs and collect the logs on this account and push it to its S3 bucket storage. Collects activity from account A and push it to here. Collect activity from account C and push it to here, and create a daily report to see what users are doing within AWS. Anyone do any unauthorized activity or anything that is not authorized or clicking around, this guy can see it and he can report to your manager. They will never contact you directly. They always go to your manager and say, manager, hey, Debo is snooping around. So when you have the one-on-one meeting with your manager, he will advise you, talk to you, hey, what's going on? What are you doing? What are you clicking around? You know, they'll give you a first warning, second warning, third time, you're gone. Okay. So please, if you're giving access to specific services, stay on those services. Don't be going elsewhere. Don't be nosy. Okay. Don't be nosy. They call it curiosity killed the cat. Don't be too curious to whatever. If you want to play with AWS, use your personal account and play around. Don't use your company account to play around. Okay, they're watching what you're doing. And then you have PCI DSS compliance. Okay, this is what allows users to put their credit card information on a website, because AWS meets this compliance, this credit card industry compliance. Multi-factor authentication is simply when you use two-factor. So you put your username and password, and then it sends you a code to your phone, and then you put the code and you log in. So this is for authentication. This is authentication security. They're going to ask you in an interview, how do you secure authentication? How do you secure users logging to services? Login to AWS, you're going to just say using multi-factor authentication. Okay? Any questions so far? Very, very easy, right? Password policy. IAM allows you to define a password policy. You can set the minimum password length to be 6 characters. It should have at least one alphanumeric character. Non-alphanumeric character, which is like a $, percent. Allow users to change their own password. Password expires every 90 days, right? And then you make all these selections. So everyone creating a password on AWS, you'll have to follow this policy. Okay? And then ways of securing AWS, you can use IAM users, you can use IAM groups, IAM roles, you can use IAM keys as well. So what are users? Users are defined as people or systems that use AWS services. Take notes of this word, systems. A user is not just a person. A user can be a system. A user can be an EC2 instance, right? A user can make S2 instance. Right? This is a web server, but this web server is a user to the application because this web server sends its requests to this application server. And this application server, on the other hand, sends its requests to the database server. So this server is a user to this server. This server is a user to this server. Your servers can be users. They do things on your behalf. The load balancer can be a user as well. The load balancer spreads your traffic across multiple servers. So it's doing things on your behalf. Look at what it says here. Users are defined as people or systems that use your resources. They do things on your behalf. An IAM user is an admin, is multiple end users or systems. Your phone is a user. You use your phone to connect to Facebook. So your phone is a user to Facebook. Your laptop is a user. You use your laptop to connect to the internet. Use, user. Use, user. Make sense? The word user has use in it. I'm going back to English language again. So a system that you use is the user. That makes sense. It's easy, right? So IAM permissions by default is not authorized to perform any AWS actions. If you create a new user within AWS, a brand new user, that user has access to do nothing. He can only log into the account. When you create a brand new user, he has no access. He can only log into the account. So you have to assign permissions to those users who can then create and manage other users or do things within AWS. Make sure when you create users, you use or permissions, use a least privilege policy when assigning permissions. What does this policy mean? Least privilege. This is another thing they ask in the interview. So if you say we implement the principles of least privilege, meaning that you only provide access or permissions to services that the user needs to do their job. You only provide services or permissions to users they need to do their job. That's it. That is it. They need to do their job. You don't give them anything. So you give them the least privilege. When you do the least privilege, it reduces the chances of making mistakes. If you don't have access to S3 or databases, there's no way you're going to delete the database because you didn't even have access to it. So there's no chance of you making a mistake because you don't have access to it. And also, it increases access permissions, and you can also increase the permissions as and when required. So they're not going to give you all permission. They're going to give you specific permission. Create, delete, describe, done. Or they say, oh, you don't need to create. They're going to go remove the create because they don't want to make a mistake and create something that is not needed and waste money. Okay? So IAM users can create and add users. All these things is just the thing we talked about already, right? Multi-factor authentication. Look at a scenario. Let's look at this scenario, guys. If you're an administrator of your company, which of the following options would you use to grant user access to your AWS account? A or B?
B.
Anyone else?
B.
I think it's A. I think the
Me
answer
too, I
is
think it's A.
wrong. Iamba. I just tricked you.
Only but well, I'm learning, but I thought normally is A because I'm
No,
trying to like
wrong.
compare.
Just talk about IAM the whole time. IAM, 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 IAM. IAM is what we use to grant permissions to users. IAM is what we use to grant permissions to users. IAM, 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 IAM. And then you see IAM here in B, and you see they're going to use somebody's password. Come on, man. Here in A, all these users are using somebody's password to log in. They're using Iyok Ayamba at geico.com and his password to log into the AWS account. All everyone see.
Okay, I did not think of it that way, but I understand now.
So when you see this icon
Yeah.
here, this means IAM. So all these users are using IAM to log into AWS. Correct answer is B. We just talked about IAM for the last 20 minutes. So this scenario, the correct answer is B. You are not going to use somebody's password to log in. If someone offers you that, refuse. Refuse. Refuse.
I was thinking that, for A, the reason why I said A was I thought that for A, they are going to use their own password, but he's going to be
No, no, no,
monitoring the activities.
no.
While for B, I thought,
No, 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 no. The
okay.
correct answer is IAM. You use IAM to access AWS. These users are using a role within IAM to authenticate. They're going to create users with IAM to authenticate. They're going to create roles to authorize into AWS. Please, please, please do not forget that. Groups is simply a collection of users. Groups is very, very simple. We don't really use groups anymore because if you delete a group, if one person leaves a group, you will have to modify that group and it can affect other people. So don't really use groups very much. And we use LDAP group, they're not IAM groups anymore. So groups are not very important, but a group is just simply, you can divide a bunch of permissions and put everyone in the same group based on their function. For example, you can create a group called SREs, and in that group, you have all the permissions to monitor everything, and you put all the users in that group. That's it. Okay? So IAM groups defines as a collection of users that inherit the same set of permissions. That's the IAM group. For example, if we go back to our diagram here, let's look at this. What is common among these three users? What's common among all three of them? I'm going to go to sets. You guys know what sets are? Sets in mathematics. Set A, set B, and set A intersect to set B, right? And then in this intersection here is C. So set A intersect B. What's common among all of these guys? Look at it very carefully. What's common? What permissions are common among this, and this? That means they exist in all three.
What is common is list S3, list S3 and describe S3.
Thank you. Thank you. That's what's common. So we can take these two permissions and create what? Monitor S3 row. Is that correct or no? It's not correct. It's wrong. Because it doesn't have what?
It doesn't have create.
No, doesn't have what?
And monitor S3.
Yes. So list and describe is only what? It's only what? Read only. S3, read only. That's all it has. Can only read, can only list and describe S. That means read only. So we'll create an S read only role. So instead of doing this, we can just remove this, and add the S3 read only role to this row. So this, like this, boom, attach it, boom, attach it. That's it. So Kobe and Joe will have database monitoring role and S read-only role. Chris and Isabel will have S monitoring role and S read-only role. That's it. So now whenever I want to modify S read-only role, we'll just come and modify it and add something in here. We don't have to do one by one anymore. Now it looks a little bit cleaner. Now we can also go and create an S3 monitoring role. And the S monitoring role has what? It has everything that you see here. Create S3. It has list S3. It has describe S3. And it has monitor S3. That's it. So that's the role that I will give to Cam. That's the role. That's his role. He can create and he can monitor, but everyone else can list and describe. That makes him more powerful when it comes to this service. But he cannot do anything when it comes to database or EC2. That's it. That's how I be on the job, guys. All of you are not going to have the same permissions. So when Cam wants to create an EC2 instance, he will open up a ticket and say, hey, Chris, I have a ticket number this. Can you look into it for me? Because he doesn't have access to do it. Any questions? So IAM groups example, you have an admin group. You have Bob and Susan in that admin group. You have developers. You have Brad, Jim, Mark, Kevin, Dev App 1, Dev App 2. These are not human beings. These are systems. These are human beings. Mark is a human being. Kevin is a human being. Dev App 1 is not a human being. It's a server. It's a server that acts as a user. Dev App 2 is another server that acts as a user. Here you have the test group. You have Kathy Allen. Test App 1 is a server that's acting as a user. Test App 2 is a server acting as a user. So you will see 14 users, but you only have 7 employees. Huh? That means the other 7 are systems. It's a server. Look at my account here. Where is it? Where is it? Users. Look at that. How many users, how many human users do you see here? How many human users do you see here? You will not know, right? It's only one. Domo is an application user. Fivetran is an application user. LCM is an application user. Sedona is an application user. Terraform is an application user. It's only one user here, Father Joe, Father Jovita, my priest in my church. That's him. He's a human user. The rest are system users. And you can tell because they're using what? They're using an access key, a programmatic key to log into the system. A human user uses password and username. A system user uses access keys. They use programmatic keys. They cannot use it. A system user cannot use the username and password to log into a system. A system cannot type a username and password. No, it cannot. It uses programmatic access, which are these keys that you see here. Okay, we're going to get into it. And you see, they don't have console access. System users don't have console access. They cannot log into the console. They cannot connect to programs, which is like code. So that for console access, they have been disabled. They cannot log into the console. Terraform, Sedona, Apache Sedona, Terraform. They cannot log into the console. They cannot sign in. Okay? So when you're creating a user, you'll see you have 2 options. Let me just do a test here. You have an option to create a user and add to a group or copy permissions or attach post directly to the user. And then you have the option to create a user, which is empty, no permissions. And you can add permissions later on. Okay. You can grant permissions to a group. You can grant permissions to developer groups. So developers here have access to EC2, while admins have access to EC2 and Elastic being stored. So another AWS service. You can define a group as a collection of users and then that inherit the same permissions, right? So developers, Mike, Jane, and Anne have the same permissions to EC2, while admins, Mark, Sarah, and Jim have access to this. Now let's check. How does AWS define a group?
A collection of users that inherits the same set of permission.
B.
Is that B or A or D or C?
B.
B.
Anybody else?
E.
I think the answer is D. D as in Debo. Who else thinks it's D? AY, think it's D or B?
I think it's a B.
Answer is B, right? And I'll start doing that, guys. I'll start tricking you guys into giving you the wrong answer to see if you're really confident in your answer. I'm gonna build your confidence. I'll start tricking you guys with that. IAM is a good population, right? That's the correct answer. Okay. Roles. Roles are identities with permission policies that determine the access to the identities, right? Very similar to users, but they're not password protected and do not require access keys. It can be assumed that anyone requires them. A role is simply taking many permissions, putting them in a policy, and creating a role. A role can have one or more policies. A policy is a set of permissions. Create EC2, create S3, list S3, create a database. That's permissions. Create EC2 is one permission. So create EC2, create S3, list S3, that's 3 permissions. You take those 2 permissions, you create a policy called create S3 and EC2 policy. That's one policy. You create another policy called monitoring policy, which has monitor EC2, monitor S3. Now you have 2 policies. Take those 2 policies and you create one role called Cloud SRE role. And you assign to Isabel, and off she goes and does her work. That's it. Very simple. A role defines a set of permissions to access the resources that a user or service needs. A role is what you need, not what you want. It's need. If you need to be a cloud SRE to monitor stuff on the job, we're going to give you what you need, not more than what you need. Users can programmatically assume a role at runtime. AWS provides temporary security credentials that a user or an application can use. Take note, users are also applications as well. Take note of that. It's very important. People forget because they'll ask you on the company, on the job interview, they'll ask you, how many users do you have? You say, oh, well, only 16 of us, the company, we only have 16 users. No. No, you say above 100 users. That's the correct answer. AWS rotates security credentials automatically on a daily basis, right? So the role behind the scenes, they have credentials that will rotate automatically. Every 8 hours, the roles will rotate. You can schedule your role to rotate every 1 hour. So you have to log in again and assume that role every hour. But the maximum is 12 hours. The minimum is 1 hour. So it depends on your company. Some companies do 1 hour, which is annoying because if you leave your computer inactive for 1 hour, when you come back, you have to log in again, which is kind of annoying. So roles are used to provide access to users, applications, and services that do not have permission to use AWS resources. Roles are also used for temporary access. If you want to be able to log in and from 8 to 5, and after 5 p.m. you don't have access, we can use roles. So in this scenario, look at this scenario here. The admin creates a role that grants access to photos. This S bucket has pictures in it. And the role permission in this role is only get pics. That's it, get picture. That's the action. One permission, get pics. So Now, this get peaks role is attached to this instance, EC2 instance that runs this application for images. The developer launches an instance with that role. The EC2 instance has that role. And now that role, the application now uses that role to retrieve. The application retrieves the role credentials from the instance. So the application running this on this instance take the credentials from that role and then uses that credentials to access these photos in this bucket. The permission here is get pics. So when we create the EC2 instance, we attach a role to this EC2 instance. Now, the developer launches an instance with that role. The role is attached to the EC2 instance, and now the EC2 instance needs to use the credentials from the role, which is the token behind the role, which we're going to see, to go to the bucket and get the pictures in the bucket. And that's it. Get pics. That's how it works. Very, very straightforward. Policies are simply a set of permissions, like I said to you, right? Or a document that defines one or more permissions. That's what the policy is. Very, very simple. You can attach users or groups or roles. You can attach policies to a user, to a group, or to a role. It's written in JavaScript object notation, JSON, right? What you see here is a JSON. This is a JSON. This is a JavaScript object notation, right? You don't have to write it. They already exist in AWS. You have to just copy and paste it in your account. Okay. Policies are selected from a predefined AWS list, or you can create your own policy. Some policies already exist, but most of the time we have to configure it. Whenever you hear configure, it means you have to create your own policy. So the policy has the following things inside of it. Actions, which lists a specific operation that you can perform. The resource is the object being protected, and then the effect is either an allow or a deny. So whenever you do allow, it means you want the person to be able to create that resource or monitor it or do something. Or whenever you do deny, it means you're denying it. For example, you look at this JSON policy here, the effect is allow. And the action is S3 list bucket. So here, what's saying that anyone that uses this policy can list the contents of an S3 bucket. And what is the resource? The resource here is the bucket name, the specific bucket. In this case, the bucket is called example bucket. So if you assign, if this policy is attached to you, you'll be able to log into AWS. You'll be able to list that bucket, the contents of that bucket. Sorry, you'll be able to list the contents of the example bucket, only the example bucket. However, if they had a star here, they replace it with a star, it means you're able to list all buckets. Star means all. If they only put the bucket name here, you're able to list or describe the contents of only the example S3 bucket. Only the S3 bucket, or example bucket. We're going to do S3 one of these days as well. So those are AWS policies. There are more than 200 predefined policies right now to choose from. But most of the time, those policies, they have things that you don't need. They have things you don't need. So you might have to go in there, take a policy, copy it, remove some things that you don't need, create a custom policy, create a role, attach the role to the user or to the group that you want. Okay, for example, administrator access policy provides full access to AWS services and resources. This is the most powerful policy in AWS. Provides you access to everything. You will never get this policy attached to you. It's very powerful. The next one is EC2 full access. If you have EC2 full access policy, you have access to create EC2, load balancer, CloudWatch, right? Full access means you can create, you can read, you can delete. You have full access. And then S3 read-only access means that you only have access to S3 to only read it, which is lists. You can read all buckets, you can list it, you can describe all buckets, but you cannot create EC2 or no other things. So read-only S policy. These are predefined policies that already exist, okay? I'm going fast because this is a very basic. IAM keys are access keys, cryptographic keys that system users use to connect to AWS. These IAM keys are cryptographically generated by AWS. The keys consist of two components. It has an access key ID and a secret access key. So this access key is like a username, and the secret access key is like a password. But these are used by other systems. We don't really use it manually as users. Users use username and password, but system users use access key and secret access key. So this is their own username and password. For systems, their username is access key ID and their password is secret access key. Okay? The key ID uniquely identifies the credentials and is considered public knowledge. So similar to how your username can be public. The access key is public. And the secret access key is usually cryptographically signed all of the requests and is considered private. So the secret access key is private. Okay, this is very private. Do not share your secret access key with anyone. If compromised, it can and must be revoked because it's like a password. The secret access key is the password. The access key is fine. If you go here, you can see on this right here. If you go back here, you see here, this is access key. This is the access key for these users. It's public information. It's public. Everyone can see it. But the secret key, you can't see it. Even if I go in here and I go to security credentials, right here, it has an access key, but there's no secret key. If I want a secret key, I might have to go generate it, like the description or create access key or create a new security key for them. Right? So you don't share that key with anyone. Okay. Now let's check. How do you assign permissions to an IAM user, group, or role?
C.
What's that?
C.
I think the answer is A. Anybody thinks different? Oh,
C.
yep. Use the policy documents. What does JSON stand for?
D.
Okay.
Yeah.
JavaScript abstract notation. In a JSON policy, what does the effect statement define? What's the effect statement define?
C.
The effect statement. Come on, guys. We just saw it just now. What is this? Allow or deny. We just saw it, right? In a JSON policy, what does the effect statement define?
A.
The effect statement define what the effect will be when a user requests access, either allow or deny. What permissions would the Amazon EC2 access policy give a user? We just saw it, guys.
A.
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 Amazon EC2 full access provides AWS direct service users or groups full access to Amazon EC2 services and resources. What is that? EC2, load balancer, CloudWatch, auto scaling. Let's go back to it. Look at S3 again. Look at S3. Look at S3. For S3 read-only, what does it provide? Read-only access to all S3 buckets. Okay. Let's go back to the question. What permissions would the Amazon EC2 full access policy give the user?
D.
Are you sure? What's the answer? B for boy or D for David? Or which one? Or C? Which one?
D.
B as in boy?
No, D as in dog.
Are you sure? 100%? Everyone give me the answer, guys. Come on. Kwasi.
It's D, option D.
Okay. This is very confident. It's D. We just saw it now, guys. Come on. We just saw it right here. Right here. 1, 2, 3, 4. Full access. This role provides the Directory Service Group with full access to EC2 services as state and resources, Amazon Elastic Cloud, Load Balancer, CloudWatch, and auto scaling. So if you use Amazon full access, can you monitor EC2? Can you use CloudWatch? Yeah, you can. Yeah, you can. What will automatically be generated when you create a new user? It's a tricky one. We just said when you can create a user.
A.
H. A.
A? Are you sure
Yes.
it's A?
Yes, it's A.
Okay, yeah. New users have an access key ID and secret key generated, which are viewable only at the time of ID creation. What is the first step when you set up an AWS account? What is the first step to do? In terms of security,
C.
D.
when you created an account, did you have to set up your AWS? Did you have to put your email address in?
Yeah, I think that's an email address.
Exactly. That's the first step, right? Yeah, so that's it. The first step is to create an account using your company email address. This would be a root account. Okay. So the best practices, you can read about it. Least privilege, only grant required permissions, don't grant more than what is needed, right? Whenever a user say, can you give me access to database? Say, what are you trying to do? Ask them. I'm trying to create a database. Okay. What do you need a database for? I need to create some application. Okay, we can create it for you, or we can open up a ticket to create it. Don't give the developer permission to create a database. Create it for them. Because when you create it for them, you're creating it according to the standards of the company and you're going to monitor it. If they create it, they might not follow the standard of the company. Do not give permissions to users without manager approval. Okay? Create strong password policies. Do all these good things. What does MFA stand for?
Multi-factor authentication.
Yeah, which number is that?
I mean,
Option D.
Delta.
multi-factor.
What AWS tool is used to track, monitor, and log IAM user activity?
Cloud storage.
One,
C.
Option D. Option D.
option D, CloudTrail. D is used to track user activity. Okay. Let's look at this scenario. As an admin for your company's AWS account, you need to assign permissions to 4 new users. 2 users require full access to EC2. 1 user requires access to AWS resources. 1 user requires read-only access to S3. Use AWS best practices when configuring the user access. So ensure you use groups. Key takeaways, that's it, done. So your homework is to go and create IAM policies, users, groups, roles, and play with these things. We are at time, but I wanted to do this setup. The first step of this setup, I can at least do it now, is to click here. And go to roles and come back here. They say choose the role by selecting the name, right? So we're gonna copy this. I'm gonna copy this. I'm gonna go on attach policies and create policy. So I'm gonna go here, create role, and go back. No, it says choose the role so you can run and create policy. So we're gonna go back here, and to cancel. I'm gonna create policy actually. Create policy. The JSON, and just remove everything in here, right? And there's a syntax error somewhere. Actually, hold on. For CloudWatch. So right here. Cancel this. Roles. Create role. And it's what's the role? So CloudWatch role. Navigation pane choose role. Choose a role by what role? Do not select the checkbox next to the name. What role are they referring to, Kwasi?
I don't know. That's what the ink. I have to create something for adding this.
This documentation is old. That's why. So normally, right, it's normally EC2 role, right? And then next, we're gonna create a policy here, right? So here, we need to then we're gonna put the policy here. Add permission here. Edit this permission here. The first thing we need to do, so the documentation is old. The first thing you need to do is create a policy. Okay, that's the very first thing you need to do. So here, we're gonna just paste this JSON in here. Come here, copy this JSON, and paste in here. And then we're going to create our policy first. So the policy here is, they don't even give you a name to put. When you're finished, choose review policy, all other reporting is in the error, other reviews, type a name and description of your choice. Okay, we want to just call it CloudWatch policy. CloudWatch, let's call policy. And then create policy. Now we're gonna go create the role and attach this policy to that role. We're gonna go create EC2. Because we're gonna attach the role to an EC2 instance. That's why we choose EC2, right? We're trying to install CloudWatch log on an EC2 instance. So we're choosing EC2 instance here. That's why. This role is attached to an EC2 instance, okay? It's gonna be more, see here, the most common uses are EC2 or Lambda. So most of the time, it'll be EC2. Most of the time, 90% will be EC2. So always choose EC2. If you are unsure, choose EC2 all the time. Now we're gonna look for that, our customer managed policy that we created. Where is it? CloudWatch policy. We just did it just now, right? That's it. Select that policy, and then we're gonna create a CloudWatch. I'm gonna just call it Debo. Let's call CloudWatch. Let's call role. And that's it. It creates the role. Next thing is done everything. Close the browser. Step 2. Install and configure CloudWatch logs on an EC2 instance that's running. First things first, we need to go to EC2. Right? Go check this box. Click on instance, actions, security, modify IAM role. And then we're gonna attach that role. Where is it? Debo CloudWatch role. Update IAM role. So now this EC2 instance has permissions to do those things. Then now we're gonna go back here. And we're gonna start running these commands now. Copy that. And connect to this EC2 instance. I know we're above time, guys. Do you guys have 5 more minutes, please? I know I was 5 minutes late. I'm begging. Okay. And then copy this. This is where some people were stuck. Let's see if it runs. Let's see. Okay. So did the command fail?
Yes, when I did it failed.
Okay, cool. So go back here. Install the AWS log package. This is the recommended method for installing the log on Amazon Linux instances. So if it fails, what do? You go check this other one right here, right? The unified agent. Remember? They said it in the beginning. Where is it? This one? Right? Okay. Let's say it failed. We continue going. Right? We continue going. We copy this command and you run it here. It failed to start the log because the log is not there. So
Jibo, what I did at this step, the version of Amazon Linux, I changed it. I used Amazon Linux 2. And when I use this, it works.
Thank you. So the other way of this is, okay, if you're trying to install the log on this and it's not working, because this is a brand new Amazon Linux 2023, and this is meant for the old Amazon Linux, what you can do is you can copy. I wanted you guys to feel. I wanted you guys to copy this error right here. You copy this, and you go to Google, and you Google it, and look at what it will tell you. AWS logs removed in Amazon 2023. And this is a solution that Amazon gave you. You need to know how to Google, guys. You need to know how to troubleshoot things. That was the purpose of the assignment. I wanted you to fail. I wanted you to go and troubleshoot it. Please use Amazon CloudWatch Agent. The CloudWatch Agent is duplicated. So this is the solution here. You have to go use a new one. That's it. That's what I was trying to show you guys. You have to use the unified CloudWatch agent if you're going to use a brand new Linux instance. And this is the documentation here. Boom. Oh, yes, this is it. So this is a new instance. No, that's not it. So if you go back here, the new CloudWatch agent, I can use the previous documentation. This is the old one, I believe, right? This is the old one. This is the same thing. Yeah, this is the same thing. Or you go look for the documentation install CloudWatch logs agents on Amazon Linux 2023. The new one. Using the command line. This is it. Sudo yum install this. Yes. And that's it. So that was the goal of the assignment. I wanted you guys to hustle. I wanted you guys to know how to fish. I wanted you guys to know how to figure it out. And now I'm installing the CloudWatch log agent. And that's it. Any questions? Can you guys do it now? Can you guys go figure it out now? I don't want to still do the assignment. I don't want to do that. I don't want to do it. This is a new step, right? Where is it? The new one we just did. Download and configure. This is it, right? This is it. All the steps. All you guys can meet as a group and do it with Kwasi. Okay? I don't want to do it. I want you guys to figure it out. Download and install and configure the Amazon CloudWatch log agent on 2023. Amazon 2023. You have to follow these things that they say here in red. Something is duplicated. So you have to go follow this one. Using the unified CloudWatch log agent. Okay. And then this unified CloudWatch agent, when you get here, you got the prerequisites. Okay. Prerequisites, you have the prerequisites, everything is set up. Then you go back here again, it's taking you back. And then you want to collect metrics, logs, and traces. So this supported operating systems. Look at that, 2023. Okay. Install CloudWatch log agents. That's it. Install. Okay. Next thing is what? Next. Next. That's it. It's only one command. Okay. It's a homework, guys. Go and perform the homework. Okay. We'll continue on Wednesday. I want you guys to figure it out. I want you guys to read.